Hello everyone, I hope you're all doing well. I'm back with another video. In this video, I'm gonna show you how to do time series analysis in Python. But first, let's see what is time series. Time series is a sequence of observations recorded at regular time intervals. And depending on the frequency of observations, a time series may typically be hourly, daily, weekly, monthly, quarterly, and annual. So time series forecasting is a machine learning modeling for time series data, for example, years, days, hours, for predicting future values using time series modeling. We want to gain some useful insights from this data. And to do so, we have to decompose the time series and look for some components. Basic but important components such as trend, seasonality, and cyclic behavior and irregular fluctuations. And based on these components and behaviors, we will decide on which model to choose for time series modeling. So, in the second step, let's go further and figure out these components. First, what is trend? Trend is a long-term increasing or decreasing pattern in the data points, and it could be linear or nonlinear. And second component is seasonality. Seasonality is a data pattern that repeats itself at regular intervals. And lastly, cyclic. A cycle occurs when the data exhibits rises and falls that are not a fixed frequency. But we should notice that a cycle is different from seasonality by way of its irregularity in frequency. And the last but not the least step before running the time series analysis is to check the stationary of properties. Stationary means that the statistical properties of a process generating a time series do not change over time. In other words, all its statistical properties, like mean, variance, and standard deviation, remain constant over time. But what if time series is not stationary? So we have to make it stationary. And there are ways to make it stationary, like differencing the series one time or more, taking the log of the series, taking the nth root of the series, or combination of all these ways. But the most common and convenient method to stationarize a series is by differencing the series at least once until it becomes stationary. Differencing series, as it's obvious, is subtracting the next value by the current value. So let's move on and see how we can distinguish stationary. The stationary of a series can be established by looking at the plot of the series. However, we need a method to quantitatively determine if a given series is stationary or not. And this can be done using statistical tests called unit root tests. There are multiple implementations of unit root tests, but we use ADH test or augmented Dickey-Fuller test. In this test, we consider that the null hypothesis, which says time series is non-stationary. And finally, after making the time series stationary, we make models on the time series using differencing because it is easy to add error, trend, and seasonality back into the predicted values later on. And finally, we will going to use a statistical modeling method called ARIMA to forecast the data where there are dependencies in the values. ARIMA is autoregressive integrated moving average, and it is like a linear regression equation where the predictors depend on parameters P and D and Q of the ARIMA model. These three parameters account for seasonality, trend, and noise in data. So now we're good to go and run the code. First, we import necessary libraries, pandas, numpys, seaborn, matplotlib, stats models, and so on. For the sake of this example and this video, I have run the code before, so we just see the results. Then we load the dataset. The dataset contains a daily sales and profit of a store in 4 years from 2015 to 2018. So you see we have 21 columns as 21 features and 9,994 orders from this superstore. From these 21 features or variables, we take a look at the categories column to see what kind of product this store is selling. So we have run the code. You see there are several categories in the store sales data. And we start with time series forecasting for the office supplies sale. And then we use slug to index office supplies category. And yeah, you see the code here. Then we want minimum and maximum of order date column, which gives us the first order and the last order of this store. So you see the dates, and now we process the data. We will remove irrelevant variables, handle missing data, and aggregate sales by date. So since we want the sales of office suppliers over the time series, we only keep 2 columns, order date and sales. So we have run the code, and then we check out missing values. So you see we have no missing values, and we move on to the next step. We aggregate sum of office supplies by date. Then we're good to go and import data with indexing time series data. And in the next step, we plot the data. We put order date in x-axis and sales in y-axis. So you see the plot. This plot is jammed to interpret. So we should use the resample function time series data by month and use the averages monthly values. So we have done this. And since all values are positive, we can show this on both sides of the y-axis to emphasize the growth. So now we visualize the trend and how it varies each year in a year-wise box plot. And we do the same for a month-wise box plot to visualize the monthly distributions. So box plot of month-wise is the seasonal property and year-wise is the trend property. You see the codes. Now let's check the stationary of the dataset. As I mentioned before, we can assume the series to be stationary if it has constant statistical properties over time. Properties like constant mean, constant variance, and autocovariance that does not depend on time. So we check the stationary in 2 ways. First, using plotting a rolling statistic, that we can plot the moving average or moving variance and see if it varies with time or not. And second, using Dickey-Fuller tests and results of a test statistic and some critical values for different confidence levels. If the test statistic is less than the critical value, we can reject the null hypothesis and say that series is stationary. So then we plot them with these codes. You see the lines of rolling mean and rolling standard deviation. We plot them with these codes, and you see the lines of rolling mean and rolling standard deviation. Now we conduct the Dickey-Fuller test using AD-Fuller. So from the results, we have the test statistic equal with minus 1.63 and p-value of approximately 0.47. And since it is not less than 0.05, we fail to reject the null hypothesis, meaning that the time series is non-stationary. In other words, it has some time-dependent structure and does not have constant variance over time. So we need to make it stationary. So there are several methods, as I mentioned before, to make a time series stationary. Take a log transform, moving average, exponentially weighted moving average, difference, and decomposition. For the sake of this example, we use the last way, which is decomposition. But first, we take a log for simplicity. And in this approach, we take average of k consecutive values depending on the frequency of time series. And here we can take the average over the past 1 year, for example, last 12 values. So we run the codes, and after that we need to define moving average. We drop non-values and check the plots to test stationary. So you see the rolling values appear to be varying slightly, but there is no specific trend. Also, the test statistic is smaller than 1% critical value, so we can say that with 99% confidence that this is a stationary series. Lastly, we get to the composition step. In the composition approach, both trend and seasonality are modeled separately, and the remaining part of the series is returned. So you see the codes. And here we can see that the trend, seasonality are separated out from data, and we can model the residuals. And we have checked the stationary of residuals. From the results, we see that the Dickey-Fuller test statistic is significantly lower than the 1% critical value, so it's very close to stationary. And we conclude that our series now is stationary. So finally, we're good to go and forecast time series. As I said in the introduction part, we use ARIMA method, and we're going to define P, Q, and D. There are 3 ways to do that, but here I'm going to use AutoArima function. In this approach, I have splitted the train and test set, applied AutoArima to decide P, Q, and D, and then got the predicted values for test set, and then plotted the train test and predicted data, and then evaluated the forecast accuracy. So we know that if the result from forecast accuracy doesn't support the ARIMA model, we should choose different methods to forecast the data. So let's see the splitted data. So we find P, D, and Q using AutoArima. You see the codes to do that. And now we build ARIMA model. From statsmodels.tsa.arima.model, import ARIMA, and we run the code. Then we predict test data set. You see the codes for doing that. So in the next step, we evaluate ARIMA model using MAPE. MAPE is defined as the percentage of the average of absolute difference between forecasted values and true values divided by true value. So the lower the MAPE, the better the model is, but our model have considerably high MAP. And we see the accuracy. So let's plot the predict value to see what can be the reason for the low accuracy. We have run the code. You see the problem of ARIMA prediction is that it doesn't show the season trend of data. And so the solution for this problem is using seasonal ARIMA, which is called SERIMAX function. We have run the code, so we got the results, and we plot forecast data. So again, we use MAPE to evaluate the model, but this time for SERIMAX model. So you see the model has improved, so we can continue use SERIMAX to forecast the office supplier's sale. We have named it future_sale, and we have run it, we have plotted, and so you see the predicted future sales after 2018 to 2019. And that was it. It was our time series analysis. I hope you liked this video and found it helpful. If you did, please like it and subscribe to my channel. And I'll see you in the next videos.